Okay, so this is the review for Unit C. So actually this says Chapter 3, but really this is Unit C. This is our Unit C review that we are getting ready for our test. So this question here looks actually somewhat familiar. A key part of this whole unit is actually knowing what the angles are. So if we look at angles 6 and 8, what type of angles are they? Those are vertical angles. Right, they are vertical angles. Angles 3 and 7, notice that, if I label these, let's say that's N, that's M, and this is L. L acts as the transversal. Now, even though N and M are not parallel, we still have 3 and 7 being in the same position for each intersection. Right? Notice that 3 is in the bottom right, 7 is in the bottom right. So when they're in the same position, we call those corresponding angles. So those are corresponding angles because they correspond to the same location. Angles 2 and 8. Well, if N and M are the lines and L is the transversal, then everything between them acts as an interior angle. So 1, 2, 7, and 8 are exterior angles. And because 2 is the exterior angle that is in the upper right and 8 is in the lower left, two opposites, angle 2 and 8 are alternate exterior angles. For angles 3 and 6, notice that these are on the same side of the transversal, and they're both interior angles. Two angles that are in the inside of, that are both interior angles and do not have any angles in between, so it's not like I have more angles in here. We call these consecutive interior angles. Angles 3 and 5. These are also interior angles, but notice that angle 3 is in the lower left, 5 is in the upper, 3 is in the lower right, 5 is in the upper left. Because those are two complete opposite locations, we're going to say that these are alternate. And because they're both interior angles, we say that they're interior. So alternate interior angles. And then 5 and 6, looking at that, we can see that they are adjacent angles, but that's not the most complete description of them. Because they're two angles that are adjacent on the straight line, we call them a linear pair. Now that's important because linear pair is always going to be supplementary. So angles 5 and 6 add up to 180 degrees. So make sure you understand these definitions, these angles, these rules. If you can do this, then really the rest of the chapter is not that difficult. Now for these problems, setting up the equation is the hard part. Based off of the diagram, there's actually no relationship you can set up. We can say that 4y minus 10 plus 3x is equal to 180, but we have two variables in one equation, and we can't solve that. However, instead, if I look here and I say, well, this is 3x, and this is also 3x. Why? Because these are corresponding angles. So by using my rule there, I can say that these corresponding angles are congruent. That means that these two angles right next to each other are supplementary because they are a linear pair. So I get 3x plus 9x plus 12 is equal to 180. So that means that 12x is equal to 180 minus 12. So that just happens to be 168. And then we have 168 divided by 12, which is 14. So x is equal to 14. Now, knowing that x is equal to 14 is helpful because if you think about it over here, I could say that these two angles are a linear pair, which gives me 3x plus 4y minus 10 is equal to 180. Looking at this equation, I can't solve without knowing one of the variables. But if I plug in 14 times 3 as 42, then what actually happens is I have this equation with only one variable. So if I have 42 minus 10, that's 32. So 180 minus 32 is going to be 148. So I have 4y is equal to 148. That means that y must be equal to 37. So if x is equal to 14 and y is equal to 37, I have my answer. And of course, I can go plug this in to check. So I can plug in, find these angles, and make sure that they are supplementary. We want to do a similar approach for angle 8, or problem 8, with these angles here. If 3y is there, then this is also 3y, because these are corresponding angles. Well, 3y and the 5y minus 4 are supplementary. So we can say that 5y minus 4 plus 3y is equal to 180. So we get 8y is equal to 184. So all we have to do is divide 184 by 8, and we get that y is equal to 23. Now, knowing that y is equal to 23 is helpful because I can look here and say, well, these two are corresponding. So from these two angles, I get that 3y is equal to 2x plus 13. But since I know that since I know that y is 23, 3 times y is 3 times 23, which is 69. So I get 69 is equal to 2x plus 13. So 69 minus 13. So I get that x is equal to 28. So I get x is equal to 28, y is equal to 23, and there we go. So don't just think that you have to use only what's there. Using our angle properties and angle rules and angle definitions, we can fill out this whole picture with what these angles are. So 3x, 4, y minus 10, 3x, 9x plus 12. And then we can get more rules. We can use consecutive interior angles. We can use whatever we want to solve these problems. So just be mindful that this is one approach. But when you have these two variables, you need to first find some equation with only one of the variables. All right, next up we have these equations, and it's going to be actually helpful for us to draw what's called a helper line. Actually, that's what the textbook calls it, and but I like it. So if I draw this, I can draw a parallel line through this point. And now I have this is 50, and that is a corresponding angle. Sorry, corresponding angle. So that's also 50. These two are consecutive interior. So if that's 50, sorry, if that's 100, then this is 80. And so what we actually have is 50 plus 80, which gives us 130 degrees. And that's nice. Over here, these are alternate interior angles because they're on the inside. So if that's 62, that's also 62. And these here are yet again consecutive interior angles. So if that's 144, this is 36. So if we have 36 plus 62, because those are the two adjacent angles, they are going to add up to 98 degrees. So it's not as simple as just adding or subtracting the angles that are there. We actually have to do a little bit of math. Okay. All right, this is a good question to really test that you know the angles. So UZW, so really it's helpful if you just trace these. So UZW is there. We can see that has that little box, that means that that is a right angle. For the next one, YZW, we write there YZW. It doesn't have the box, so it's not a right angle. And actually, it's inwards on itself. So we can actually say that this is an acute angle. TZW, so TZW. Notice it includes that 90-degree angle, and then it goes a little bit further. So that is going to be an obtuse angle. Oh, and let's do purple. UZT, right there. So we know that that's going to be an acute angle as well. Okay. Now for a problem like this, this looks familiar. For a problem like this, first off, label this. This is a right angle, so that's 90 degrees. If we have an intersection point of two lines, so we have 4 angles here, and we know the measurement of one angle, we can figure out all the other ones. We have vertical angles, so that's 40. And we also have supplementary angles from a linear pair. So that's 140, and that's 140. Knowing that A and B are parallel, we know that this is 40, so this corresponding angle is also 40. Following these lines, we can see that these are vertical angles, so that's also 40. I'm actually going to rewrite that so it doesn't look like a 90. Corresponding angles, well, first off, if this is 90, then all these angles around here are 90. Corresponding angles mean if this is 90, this is 90, and we have vertical angles here to make that 90. Now a straight line is 180 degrees, so if we have 40 plus 90, which is 130, we must have 50 degrees to get to 180. And again, looking at vertical angles, we get this to be 50. So I think a lot of people did well with this question, but just make sure that you can follow through and take each angle one at a time and look for vertical angles and corresponding angles, as those are the most important. All right, then the proof. We had a whole packet of proofs, a whole bunch of proofs you could look at, and I really suggest you get some more practice with proofs. But with our proofs, we're going to have 2 columns. So we're going to have our statements, and we're going to have our reasons. So in looking at our statements, we have 1. I don't like how crooked that line is, so we're going to make that nice straight line. All right, so 1 is going to be what's given. So angle 2 is congruent to angle 1, and angle 1 is congruent to angle 3, and that's given. Number 2. Well, let's work backwards, right? So we want to prove that ST is parallel to VU. Well, if we use this as a transversal, we can see angles 2 and 3. So if we can prove that angles 2 and 3 are congruent, the lines must be parallel because angles 2 and 3 are alternate interior angles. They make that Z pattern. Well, if I know that 2 is congruent to 1 and 1 is congruent to 3, I can actually say that 2 is congruent to 3. That is the transitive property. Look familiar? Right? If A is equal to B and B is equal to C, cut out the middle, man. A equals C. So if angle 2 is equal to angle 3, alternate interior angles are congruent, so that means that ST is parallel to UV. And yet again, we can say when alternate interior angles are congruent, lines are parallel. And it's as simple as that. So that's the only proof in this packet, but don't forget I gave you that packet of 11 problems. You can find that on the website with answers worked out for that. There is no video going through, but if you do have any questions about that or anything else here, please stop by during tutorial or around the building. Ask me questions. do the best you can studying, but the important part is you know these angles. Once you know these angles, the rest of it just falls into place. All right, good luck.